Okay, this one right here, it says, the residual plots from 5 different least squares regression lines are shown below. Which of the plots provides the strongest evidence that a regression line is an appropriate model for the data and is consistent with assumptions required for inference? Okay, guys, so what we want to make sure, these two have patterns to them. We don't like curves. That tells us that a linear model is not appropriate. This one is the most regular out of all of them. Do you see how these are? This is a huge difference between these are huge residuals, right? Whereas these are all pretty consistent. So there's no pattern, and it's around the same average distance for each point. This one would probably be the second best one. I had a lot of people choosing this one. But remember, you want the one that where everything just appears to be the most normal above and below. Okay. Okay, so which of the following statements best summarizes the meaning of a confidence interval? So, understand that the 95% confidence interval means that 95% of all random samples of 50 students from this population will result in a 95% confidence interval that covered the population mean number of hours of sleep per day. Okay? So, A looks pretty decent, but B is the best. Remember that confidence interval is 95% of all the times that we choose that sample. Okay, so 23. A local company is interested in supporting environmentally friendly initiatives such as carpooling among employees. The company surveyed all the 200 employees in the downtown offices. Employees responded as to whether or not they own a car and to the location of the home where they live. The results are shown in the table below. So this is just interpreting that table. It's A. Okay. Next one. A random sample of 432 voters revealed that 100 are in favor of a certain bond issue. 95% confidence interval for the proportion of population of voters who are in favor of the bond issue is. Here's the general formula for a confidence interval. Let me just write that down first. All right, so there's your general formula, and that's in the, well, the general formula is given to you in the formula sheet, and then this is given to you on the formula sheet. When you're dealing with proportions, you have a Z critical value, and when you're dealing with means, you have a T. Okay. Okay. Okay, moving on. All right. The commuting time for a student to travel from home to a college campus is normally distributed with a mean of 30 minutes and a standard deviation of 5. If the student leaves home at 8:25, what's the probability that the student will arrive to college no later than 9 a.m.? So we're trying to take the probability that it's less than or equal to 35 minutes. Later than 9 p.m. I'm sorry, not no later. So it's 1 minus this probability. We're trying to get and that's just a normal CDF or a table. Okay. So here's another one just using that. Did I just give you this? No. Another one just using that formula sheet. 79% of adults aged 18 years and older in the United States use the internet. A broadband company believes the percent is greater than it was in 2009 and will conduct a survey. They plan to construct a 98% confidence interval to estimate the current percent and wants the margin of error to be no more than 2.5 percentage points. Assuming that at least 79% of adults use the internet, which of the following should be used to find the sample size n? Okay, so this is solving for n. We have the percentage, which is 0.79. And then to get the z, I wanted to remind you, to get the z value, the critical value, you do second vars inverse norm 1 minus 0.98 divided by 2. Because it's a 98% confidence interval. So you get 2.33. So you can already rule out A and B, right? And this right here is your margin of error. Okay. So hopefully you guys are starting to feel a little bit better about some of these. Manufacturer claims brand A battery lasts longer than its competitors. 9 batteries of each brand are tested independently, and the hours of battery life are shown below. Provided the assumptions for inference are met, okay, so we've done that. Which of the following tests should be conducted to determine if brand A batteries do in fact last longer? So remember, brand A, a one-sided test is always greater than or less than. A two-sided is just that they're not equal to. So we want to do a one-sided test. And then a t-test is with means, and z-test is for proportion. So we're looking at means, average our means, right? So we're doing a 2-sample t-test. It's right up there. All right. And the next one. So it's really just understanding which is for which. So an experimenter conducted a two-tailed hypothesis test on the data and obtained a p-value of 0.44. If the experimenter had conducted a one-tailed test on the same set of data, which of the following is true about the possible p-value that the experimenter could have obtained? So the p-value is that value divided, the new p-value is that value divided by 2. So you could do that value and 1 minus the p-value divided by 2. So those are the two possibilities. Okay, that one was a tricky one, I thought.
Okay, I'm confused. Like, if it's only a one-tailed test, like, why do we have 2 answers?
It's a two-tailed.
But as like,
If it was one-tailed, it could have been, oh, I'm sorry. It could have been above or below. So you could have done 0.44 minus 0.22 or 0.44, yeah.
which side?
Yeah.
Was lower. Okay, sorry.
No, you're fine. Don't apologize. Okay? And 1 minus 0.22. I'm sorry. Okay. Yay, we keep going. All right, so a randomized experiment was performed to determine whether 2 fertilizers give different yields of tomatoes. Total of 33 plants were grown, 16 using fertilizer A, 17 using fertilizer B. The distributions of data did not show marked skewness, and there are no outliers in either data set. Here's the results. So this one you actually had to do a difference in means. Okay? But they gave us all of the standard deviation and everything that you needed. So a big clue as to why you had to run this test was because they gave you all the information, but they didn't give you, obviously, any p-values. So when you're doing a significance test, you have to be able to calculate that p-value. And it is a difference in means. But what was nice is that they did give us all the information. So it's just plugging and chugging into a formula. Or you could, again, use your calculator, a two-sample t-test. Or a difference in means. Okay? All right. In order to plan for its next advertising campaign, the Trendy Motor Vehicle Company is investigating whether the type of vehicle and color of the vehicle are related. Each person in a random sample of 275 selected from was classified according to the type of car or truck and the color of the vehicle he or she drove. The data are shown in the table below. What would I do? We are looking at categorical variables, and big hint, guys, we're looking at a two-way table. Okay? Two-way table usually means chi-squared, and we're checking to see if they're related, so that's chi-squared test for independence. Okay? So really know which test to use for which situation.
That's really just testing like how well your experiment or whatever fits your data. Like that's
Okay, there's three different chi-squared tests. The chi-squared test for distribution tells whether or not you have one sample, and that tells you whether or not that distribution of that one sample matches the population, right? The other two are testing usually with two-way table, and this one is the most common, which is a chi-squared test for independence. It tells you whether or not these guys are related, if there's any association between the two. Okay? It's a very good question.
so. Is it the same thing as the association?
Yes. Yes.
They're the same thing.
Yes. Whether they're independent or, yeah, association and independence, the same test.
So they're interchangeable.
Yes, yes.
Thank you.
Uh-huh. Okay, almost done, guys. Hang in there. All right, so this one, a large number of randomized experiments were conducted to determine whether taking a particular drug regularly would decrease the chance of getting a certain disease. For each of the experiments, the drug effect is the difference between the proportion of people taking the drug, blah, 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 blah. If the drug has no effect whatsoever, which of the following experimental results will be anticipated? So p-values will be greater than 0.5. Remember, if it's less than 0.5, then we reject the null, right? And our difference in means, we're expecting our null hypothesis, our difference in means, to be 0. There will be about an equal number of experiments showing positive and negative values of the drug. That's a great one. So far you already know it's 1 and 2, at least, right? And then when there's a 95% confidence intervals for the population, the drug effect are constructed. These confidence interval include 0 about 95% of the time. So remember, when you fail to reject your null hypothesis, you have 0 within that confidence interval. You have negative and positive values. Okay? So one side of that confidence interval is positive, one side of that confidence interval is negative. Okay? So that's when you fail to reject the null hypothesis. Okay? I understand the relationship between those two. Okay? We did that a lot in chapter 10. Okay? All right. As part of a class project at a large university, Amber selected a random sample of 12 students, blah, blah, blah. And, okay. Margin of error. So we had to do, okay, this is one of those ones where, this is from chapter 12. Okay? So this confidence interval is where your degrees of freedom is not minus 21, it's minus 2. And minus 2, okay? So you're using your margin of error, and this is your standard error, the coefficient, which is nice when they give you these tables. So remember, your margin of error is equal to the, what is that called? The standard error times, not the point estimate, but the, thank you, critical value. I couldn't think of it. The critical value times the standard error. Okay? It's very similar. That's why if you do this Khan Academy, it's very similar to what we've been doing. So I've been noticing the people that have been doing them get an easy 100 on that quiz and test, and that will boost your grade up significantly. So I would suggest doing that. Okay, and what's a bit dead giveaway is that you're using this table that's a Minitab output that tells you regression, right? You're doing some kind of regression.
Why don't you divide that by the square root of 12?
Because they're just asking for the margin of error, and they give you the standard error right here.
Okay.
Right? It's just from the table. Okay. All right. This one I had to do a little bit more calculation. So I probably would have skipped this one, finished, and then come back to it. All right. So we want a so you want an expected value that's over $2, right? This is why this one I would have gone back to. This I definitely would have, but just go ahead and draw this out. So here's the expected value for eliminating 0 choices, 1 choice, and 2 choices, right? Once we get over that $2 mark, it's advantageous for us to okay. It'll take you a minute to write it down, I'm sure. All right, can I move on? Definitely walk through this and read through it and try to, I had to read through it a couple times to really see what I had to do, and that's why that's a dead giveaway that's the one that you deal with at the end, right? You know, choose your best guess at the moment and then go back to it, okay? Because this is well over the 2-minute mark for calculating. So for number 34, that's a conditional probability. So probability that it stops given that it's damaged. So probability that it stops and it's damaged is 0.04, and then the probability that it's damaged is 10%. So you divide that. All right. Okay. So what is appropriate alternative hypothesis? So perchlorate is a chemical used in rocket fuel. Of course. People who live near a former rocket testing site are concerned that perchlorate is present in unsafe amounts in their drinking water. Drinking water is considered safe when the average level of is 24.5 parts per billion or less. A random sample of 28 water sources in this area produces a mean of 25.3. Which of the following is an appropriate alternative hypothesis? So we're saying that, okay, we know the mean for this sample is 25.3. So we're saying our alternative hypothesis is we know it's greater than that safe amount, okay? Remember, don't use the sample mean or proportion in your null and alternative hypothesis, okay? So let me write that down. Don't use okay, that's very, very big. So you always want to go with what they say for the population. So obviously we don't care what the mean was. We want to make sure it's not above that scary amount. Okay. All right, moving on. Only 5 more, kiddos. Okay, the computer output below shows the result of linear regression analysis for predicting the concentration of zinc from the concentration of whatever. So which of the following statements is a correct interpretation of the value 19.0 in the output? So this is, remember, this is your y-intercept, and this is your slope. Thank you. Okay, so just know how to read these data outputs. Okay? So they're not telling you what it is, so you need to know. They're not telling you what it is, so they're assuming you need to know which one's slope, which one's the y-intercept. Okay? And just as a hint, guys, your constant is your constant in your equation, right? And that's directly after this. Okay. And it's a positive slope, so be careful. Okay, so there were 5,317 previously owned homes sold in Western City near the year 2000. The distribution of sales prices of these homes was strongly right skewed with a mean of 206 and a standard deviation, blah. If all possible simple random samples of size 100 are drawn from this population and the mean is computed for each of these samples, which of the following describes the sampling distribution of the mean? So the mean would stay the same. The sampling distribution would change to the standard deviation divided by the square root of the sample size. All right. So hopefully these are starting to come back to you a little bit. What is the appropriate null hypothesis? So again, this is really just a reading question, I think. You remember that null is usually there's no difference. In the means. Okay. So some of these should be pretty quick for you. All right. For roll of a fair die, each of these outcomes. Okay, so I noticed a lot of people. So it's going to, if you're going to be doing this, if you're rolling 500 pairs of dice, remember that as you roll, do more and more times, it's going to get more normal. So these should be your two choices, but what you had to pay attention to, the green has to be centered around 0 and all outcomes are not equally likely. So we've got right around here, so it should be more of that one. Remember the distribution of the differences. Okay, so that was a key thing. So it's going to be, eventually it's going to peak at 0. There's going to be no distribution. No difference, mean. Okay, and then the last one is n is equal to 10 only. The more trials, the closer you get to the true probability. So this one was kind of a tricky one, where it says the probability of winning a certain game is 0.5. If at least 70% of the games in a series of n games are won, the player wins a prize. If the possible choices for n are what? So what happens is they told you the probability is 0.5. So as you get higher and higher number of trials, you're going to get closer and closer and closer to 0.5, not 0.7. So 10 is really the only one that would work. Okay, so if you do not trust yourself to hold on to these, you can hand them in to me because this is